Okay, well, let me start things off by thanking you for taking the time to attend our presentation this afternoon. My name is Lance Zurich, and today I'm going to take a brief look at the two special curriculum-based sets from Studica that we've designed for introducing students in middle schools, high schools, and in homeschools as well to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start off, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, what they're essentially talking about is the urgent need to prepare our students with the background that they're going to need to successfully compete in the job market they're going to be graduating into. Now, in the employment market that once greeted our grandparents or even our parents, good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the more technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and all sorts of rapid advances in all aspects of technology. Because of this, in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over this last decade has been on developing STEM skills. Every new advantage we enjoy, such as, for example, the tablets and the smartphones that all of us use every day, all of these things were created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances while preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of students with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also be part of the next wave of advancements that we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, let's now move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All, of course, extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how highly prized are they? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. Pretty nice. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they, of course, need to start developing the habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, and it's whether you're in the classroom or the homeschool, is, of course, finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts and ideas just to be able to take a test or two and then promptly forget them. No, the best help students to be successful and to really encourage them to consider pursuing further education in subject matter such as this, educators need to be able to present the material in a way that makes it relevant, which means, of course, answering the eternal student question, which is, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than textbooks and lecture presentations. And it has to be something that has real world applications in which the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which was designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject of mechatronics. These were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. And this, of course, means that solving the problems that arise at each unit require the students to be actively involved in the research, in the design phase, the trial and error and experimentation phases and activities, and in the building of actual working prototypes that will help to provide the required answers. And students aren't asked to do this alone. No, they're going to be asked to work in small groups or teams of 4 students each. This is designed to help develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, when we're talking about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable software programming, which actually it's not only affordable, it's actually now free, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. Now, the curriculum is designed to enable educators of all backgrounds, even teachers from non-science or technology-focused disciplines, to have all of the information they need at hand to properly prepare them for conducting the activities and to increase their own comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow and provides a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system that they're going to use to address the projects that are presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging, real-world style scenario where students must work together in small teams. Again, these are groups of 4 students to create a solution to the problem. The project units each contain embedded academics, and at the end of each of these units, the students will be required to make a formal presentation of the prototype that they have created to address that particular unit's real-world scenario, and to explain the reasoning behind the way they constructed their particular prototype. There's also a technical literacy task driven by each of these projects. As they work to address each project, students will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are all acquired through the carefully designed enabling activity. And again, it's required by each project. Students will be asked to create original prototypes and any required programming-based solutions, and also to maintain detailed documentation during the entire process. Now, as I mentioned a few times already in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White, and you see Tom on the screen right now. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for both educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. And currently, Tom is the Director of Technology for STEM Curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. And these will include the college and career readiness standards for mathematics, reading and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. Now, when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as too abstract to ever really be useful in their own lives. But with this project-based approach, students get to see firsthand why these things are necessary and why they're useful. The concept of working in the small groups, again, to solve these problems, helps students to develop the high demand soft skills that employers look for, excuse me. Again, things like communication skills, analytical skills, quantitative skills, flexibility, adaptability, and problem solving, to just name a few. Now, in this project-based format, all of the subject matter is integrated. This means that, for example, the math is integrated with the reading and the writing and so on, all of which is ideal for a true STEM education. And also because the manner in which students must approach each of these projects being put forth in the curriculum, again, with all the research, the testing, and the group give and take that's involved with these things, it allows for a much deeper exploration of problems than traditional teaching methods might allow. And the projects presented in each unit are also designed so that, for example, if you had several groups in your classroom working on the same project, what you should see are variations in their prototypes and their solutions. Now, this can be because of course, differences in creativity between the different groups, or differences in the research and the approaches that each of these groups are take. But in any case, students get to see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge that they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, evaluation, and redesign phases of each of these solutions. And once again, the Studica Mechatronics program sets are designed specifically for students to work in groups. Each set is going to contain enough materials for teams of 4 students to use. The team approach, as stated before, helps promote soft skills, again, such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of class sets that you're going to need. And once again, everything you need to conduct the program, with the exception of the programming software I've already mentioned, which we will talk about at the end of the presentation, everything else is included right inside the box. Access to the free curriculum download is included with the purchase of each set, and also included are all of the building materials which students will use in the creation of each of these prototypes. Now, it just so happens that the materials all come from the unique Fisher-Technic building system, and among the components used in each of these sets are 2 robotic controllers and power supplies. Now, of course, for those of you who may not be familiar with Fisher-Technic, allow me to provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction systems that are designed to primarily stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system, as you'll see from the graphic on the screen, is unique in that it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and they lock in place using a tongue and groove assembly method. And the system also includes a very wide selection of very, very specific parts. Variations, for example, on gears, on girders, sensors, and so much more. And this will allow technical builders to address equally specific design needs. Just to continue, Fisher-Technic was created back in the 1960s by German inventor Arthur Fisher, who you see here. He was noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher-Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, and he's also credited as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them to put up shelves or what have you. And of course, there's many other variations. Now, his company, the Fisher Group, still employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, and also many components used in automobile manufacturing, as well as providing consulting services related to high-end automated processes. Now, with that all being said, let's begin looking at each of the two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who might like acronyms, you could refer to this one as SIM. Now, the set is designed to help provide a well-rounded introduction to the core concepts behind mechatronics. Each set contains access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, again written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. Now, as such, we recommend this program set for insertion either into regular related class activities. It could be used as a short class unto itself. It could be used for after-school program use, or of course for homeschool use if you wish. The curriculum created for the set is, again, standards focused. We use the academic standards most widely recognized in the U.S. Education today, and this is designed for offering a project-based program. The set is designed for use in middle or high school classes, or again for addressing the same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fisher Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and much more, as well as, again, 2 robotic controllers and 2 power supplies. Only the required robotic control software, which I'm going to discuss at the end, is not included in the box. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and the project units are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that come up during the course of the curriculum, things such as sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, digital branching, analog sensors such as the photocell LDR, analog branching, analog sensors such as the NTC resistor, and as the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered in the second set. And the second set is the Studica Teaching Applications of Mechatronics Program, or again, if we were going to use an acronym, you could call it STAMP. Now, this set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to a free downloadable 400+ page curriculum document entitled Mechatronic Applications, again by Tom White. The activities and materials in this curriculum document, when used in conjunction with the contents of this set, are designed to fill approximately 180 academic hours. So essentially 4 times the amount of academic hours is covered by the first set. And as such, because of this, you can really see this as a much more expansive version of the material touched upon in the first set. And it's designed for those educators who are really able to dedicate a daily class period of approximately 50 minutes a day for 5 days a week, or the equivalent every week for a full academic year. Now, again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. Now, the materials in the set consist of a selection of over 1,200 Fisher Technic building components. And again, this is going to include a wide array of gears, blocks, sensors, axles, and much more. And again, you get the 2 robotic controllers and the 2 power supplies, and the software, which we will talk about at the end again, is available separately. Now, there are twice as many project units included in the Studica teaching applications of Mechatronics program set as there were with the previously discussed set. And this is going to include units on sketching and documentation, simple machines, mechanical systems, basic electricity, as well as project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize, and this will include sections on sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming and digital branching, learning about logic gates and combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and also working with data. Now that we've had a look at how each of these sets differs and the specific subject matter that's covered by each set, let's now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each project unit, and as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. In each case, the curriculum is also designed to be essentially turnkey. And what I mean by that is that each unit is designed to clearly spell out everything being addressed. And again, it's designed to provide tutorials and other information as the topics arrive. Now, this was done specifically to enable teachers from all kinds of backgrounds, and this means also those teachers who come from a non-science or a non-technology focused background. But basically, what we want to do is to make teachers comfortable with delivering the material and by providing a review of each section before they present it in class. So essentially, if you're the teacher and you're presenting this and you haven't worked with this type of thing before, if you can basically review each unit before you present it, it should provide you with enough material and enough background, again, so that you should feel comfortable in working with this. Each unit presented in the curriculum for each of the sets will include sections on the following. It will include an introduction, an area where the purpose of the project is discussed, the concepts are outlined, there's again an outline of what's going to be covered in the project, the standards that are going to be addressed, there are going to be assessment rubrics provided. There is the essential question, and then the student scenario. I touched on this before, the real world style scenario that the students work with. There's a daily plan, there are vocabulary words, and there are other resources presented. So with that, let me just grab a quick sip of water, and we're going to take a look at each of these sections in a little more detail. Actually surprised that I got that far without needing water. First part is going to be the introduction or the purpose of the project. And the unit always starts with this introductory section. And just as you would likely gather from that name, this is the section that provides a brief description of right at the top that's going to be what's going to be explored in the coming days and the activities. And this is also the section that seeks to clearly spell out to the students why they are learning this material and why it is important for them to know. The next section focuses on the main concepts to be addressed in the unit. And these are, of course, the broad ideas that are going to be explored in the unit and the core information that students should take away from this project that's going to really be essential for them to understand and utilize, not only today, but also to draw upon as they move forward, or you would hope, in STEM fields of study, or if they chose to pursue it further, STEM-related careers. Following this, we encounter the outline. And in this section, we drill down more specifically to what's going to be addressed in the particular unit. As the example that you see that I'm sharing on the screen right now is taken from the unit that addresses aspects of programming. you will see that we touch upon areas such as the methods for writing programs, things like flow charts, word problems, and so on. Program characteristics, for example, open or closed loop. Branching, is it digital, analog, subprograms, and so on. The next section of each project unit will focus on the specific academic standards which are going to be addressed in that unit. As you will see again, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project also contains rubrics, and these will include both rubrics for the specific project being covered, along with general rubrics for literacy tasks. Next, we encounter the essential question, and this can really be thought of as the big picture question that will be focused on in each of the smaller individual activities that are going to be addressed during the course of the unit. And of course, all of the aspects of the larger project, which students are going to be asked to complete in this section. Next up, the student scenario is where the specifics of the project to be addressed are finally, clearly spelled out. And this is presented again in the context of a real world style scenario where students are presented with a problem that needs to be solved. And it's going to require the creation of some sort of, let's say, a device, a machine, a mechanism, what have you. Now, as I mentioned before, students aren't doing this alone. They have to work in teams of 4 students to craft the answers to these challenges. Now, solving this problem that they're going to be presented with requires each team of students to design a unique and original answer, which once again will usually be in the form of a working prototype along with whatever programming may be required, depending on the particular mechanism they're going to be doing. Now, just to provide an example, if you can look closely at the student scenario that I'm showing on the screen right now, you're going to see that the project in this unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. And in this particular case, students are being required to design a specific type of control system for a new line of garage doors. And the manufacturer's requirements are all spelled out, such as in this case, the fact that the students have to use limit switches, that they have to meet certain safety codes that are required, that require, let's say, a method for sensing if anything is in the way of the door closing. And they also have to incorporate the use of an automated light. So again, each team of students are going to be asked to create both the unique and original prototype. In this case, it's going to be a garage door opening system. And they also have to create the programming needed to control the prototype. Now, as the students move through the challenge being put forth in the scenario, each student team will be required to document the entire process that they're going through in both a design notebook and a digital engineering journal. They have to, of course, note all the research, all the trial and error experiments that they perform. They have to keep copies of any design sketches that they create, any revisions they create, and so on. And at the end of each of these project units, each team of students is going to be required to make a formal presentation in front of the class, during which they are going to be asked to demonstrate their prototype and, again, the programming. So demonstrate these in action, much as would be required to do if you were working for an actual employer or client in the real world. Now, the next section we encounter is the daily plan. And this is the section that clearly spells out, both for the students and the teachers, what's going to be expected of the students each day and how the teacher is going to conduct that day's classroom activities, as well as what specific subject matter is going to be covered. Now, some days may involve, let's say, discussion. Other days might involve research or building smaller projects that are going to help provide the seeds needed for students to draw on to complete their larger projects as described in the student scenario. But in short, you can think of the daily plan as a roadmap designed to keep everyone on the same page. You will also see, too, that along the way, as different aspects are addressed in each day's activities, such as, for example, what's going to be required in a design notebook, or how to use the control software, or working with the controller, or the flow charts, or so on, that as you encounter each of these things, there are little links within the curriculum that will provide further instructions and information on each of these areas. Now, with the completion of each unit, after the last day of the daily plan, there is also a section containing vocabulary. And these can be thought of as important words and terminology that are introduced during the project unit, as well as a selection of useful resource material. Now, these could be resources that contain a mix of different types of materials. Could be carefully vetted websites and video links. It could be PDF documents, PowerPoints, what have you. It's going to depend on, which unit you're in. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher-Technic building system. And this will include information on how the various parts fit together using the pin and groove assembly method that I touched on before, how to identify the different types of parts from the various types of girders and blocks and the different types of axles, gears, rivets, and so on. And also students get to build a very basic sample model just to help them familiarize themselves with this building system before they move on to the larger projects in each unit. And as learning about and maintaining proper documentation is one of the areas that we really stress in the course of the curriculum, there is a section which details just what defines each type of documentation that we list on the screen right now and what's going to be required for each. And as the process of conducting these types of more open project-based class activities might also be a new thing for a lot of teachers, there is also a section that discusses specifically project-based STEM education and its benefits. And that pretty much completes our overview of these two sets. So with that, let's quickly review the contents and purpose of each set, but this time we're going to include some pricing. First, we have the Studica Introduction to Mechatronics Program set, which is designed again as a standards-focused project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, again, when used in conjunction with the building materials included in the set, will provide teachers with enough activity material to fill approximately 45 academic hours. Again, it's designed for those educators who wish to offer a shorter class on this material, who wish to use it in after-school programs, or of course for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials included in the set include a selection of over 700 components, and this is again going to be everything from blocks, gears, sensors, and much more, all of which come from the Fisher-Technic building system, and it will also include 2 robotic controllers and 2 power supplies. And these materials are what, again, is going to be used to construct the various mechanical prototypes that are addressed in each project unit of the curriculum. There is software required, and we're going to touch on that in just a moment. Again, each set is designed to be used by a team of 4 students, with pricing starting at just $699 for a single set. Discount classroom pricing for groups of 20 students and up is available by quote upon request. Next is the Studica Teaching Applications of Mechatronics Program set. And again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, all based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. When used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. And again, this is designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent. If you do a longer period one day, that's your choice. But either way, you have to do this for a full academic year because it's a lot of hours to fill. The set is designed for use in middle schools and high schools, and again, by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher-Technic building system, again, girders, blocks, sensors, axles, and much more, and of course, the 2 robotic control units and the 2 power supplies. Software is required. We'll talk about that again. Again, each set is designed for use by teams of 4 students at a time, with pricing for a single set starting at only $799 per set. Again, we do offer discount classroom pricing for 20 students or more, and that is available by quote upon request. Now, as I've talked about the software several times, the software is in question is the Fisher-Technic RoboPro software, and this is essentially graphic programming software. And what this means is that it uses a flowchart style design using various icons, which students arrange and link to create the programs used for each model. It's ideal for teaching the fundamentals of programming to users of all levels. Now, as you see up there, it's for Windows 7, 8, or 10. It's not for Chromebook use, sorry to say. We used to have a price on this, but not long after we created the webinar, it turns out that the software is now available for free download from the manufacturer's website, fishertechnic.de. They've changed their software around a little bit, so if you did go on the website, make sure that you're getting, if you're downloading this for the use with the program, you have to download this version of RoboPro and not the version called RoboPro Coding, because that uses a different controller. And of course, if you purchase this and you have any issue with connecting up with that, we can also get you that software as well. So on that note, if you did have any questions, this would be where, as I mentioned at the top of things, you can use the webinar chat window or the question and answer window, either of which should be located on the Zoom toolbar. If you have any questions, please just type them in. While I'm waiting for that, I'm just going to move to the next slide because it's got more information. But if you wanted to have, if you did have any questions, you could feel free to type those in. Otherwise, you could just do this. You could take the next step by, if you want to request a quote, if you'd like to speak with your dedicated educational representative, depending on what state you're located in, all you have to do is call us toll free at 888-561-7521. For any inquiries, if you're not sure who your rep is for your state, you can just email us at info at Studica, Studica.com. Or if you have any questions for me specifically, Lance, you can email me. My email address is lance.zurek, as you see, lance.zurek at Studica.com. So that pretty much covers it. I want to again thank you very much for taking the time to attend today. We look forward to hearing from you, and we hope you have a great day. Take care.